is easier than multiplying and dividing, but when you're talking about rational expressions, the opposite is true. So the easy ones are the multiplying and dividing, because it's just top times top, bottom times bottom. Whereas when you add and subtract, you have to get common denominators. So there's definitely an extra couple of steps in there. And then we'll go through the bookwork together. And then just a reminder that the test is Wednesday, the 25th. And to take it earlier, you may, the 24th, right after class. Okay, so if this not. There we go. So this is the steps for adding and subtracting rational expressions. You first have to get a common denominator. Then you keep the denominator and combine the numerators, and then you simplify. So let's look at that. So for example, a lot of times people get the lowest common multiple and the lowest common denominator mixed up with the greatest common factor. It's totally the opposite kind of thing. So an LCD, an LCM, they're really exactly the same thing, except for LCD is just referring to the lowest common multiple for the denominators. So that's why it's called lowest common denominator. So if you're asked to find the LCM, for example, on 3x squared and 12x, you're being asked to find the smallest number that both these things will divide into. And so what I normally do is I pick the bigger of the two numbers. Like here, I pick a 12 and ask myself if the 3 will go into it evenly. And if the answer is yes, then that is the number I pick, 12. If it's no, then I take that 12 and I multiply it by 2 and see then if the 3 will go into it, and just continue that process until I find a number that the 3 will go into. Generally speaking, that works. And if we come to one that it doesn't work on, we can look at all the factors. Then when I'm looking at the variable parts, I always take the variable part that has the bigger exponent. So x squared would be it. And then just to check, I say, is 12x squared evenly divisible by 3x squared? It absolutely is. Is 12x squared evenly divisible by 12x? It is. They both will go into 12x squared. So then if they ask for the lowest common denominator, it's going to be exactly the same thing. So here we're looking at these two numbers, and it would just be 12x squared. And in a minute, we'll talk about then what do we do? Okay, so to me, the most difficult part probably is finding the lowest common denominator and then making the two fractions or rational expressions match. When we talk about a rational expression, we're just talking about fraction, just another word. Okay, the first 4 problems in the book already have common denominators. So these are the first 4 problems for this section. So let's just get them out of the way because the hard part is already done. So on this first one, we have 2 over 15 plus 7 over 15. When we're talking about fractions, like when we say 2/15 plus 7/15, we're saying we have 2 of this type fraction plus 7 of the same type fraction. So we just keep the type of the fraction that we have, which is 15ths. And then if we have 2 of a kind plus 7 of a kind, that would make 9 of a kind. So you keep the denominator, add the numerators. And then if it is reducible, you want to go ahead and reduce. So both 9 and 15 have a common factor of 3. So 3 goes into 9 3 times and 3 goes into 15 5 times. So the final answer would be 3/5. Okay, so I would like somebody, Timothy, will you tell me how to do 77?
He said hello in the chat. I don't know if his mic's maybe not working.
Oh, okay.
I can read it if he says it. I don't know.
Was he chatting?
He said hello. I don't know.
Oh, hi, Timothy. Can you talk or not?
Yeah.
Oh, let's see.
I am recording.
Okay. Okay. Hunter, can you walk me through this?
So this one is the 3c over 4c minus 5 plus 5 over 4c minus 5.
That's right.
All right. Adding those together, excuse me, should get you 3c plus 5 over 4c minus 5, right?
That is exactly right. And that is as far as you can take it. So don't try and cancel C's or 5s or anything, because remember that plus sign, it's like a rope that ties the 3C and the 5 together. You can't cancel one without canceling both of those as a combined factor. And that 4C and the 5 are also tied together. So that would be as far as you could go. So basically all you did is you kept the denominator, the 4C minus 5, and combined the numerators using the sign right here. Okay. Aurora, do you think you could walk me through number 83?
Would you just do the same thing? Would you 9a squared minus 49 on top with the 3a minus 7 on bottom?
That's exactly right. You keep the denominator, 3a minus 7, and because there's a subtraction problem, you're going to subtract the numerators. Now, can you see anything that you could do at this point? Is anything standing out to you?
Would you square root the top?
Okay, so here's a hint. What is this right here?
Perfect square.
Difference of two perfect squares. So what can you do with that? How does that factor, in other words?
3a minus 7, 3a plus 7.
That's exactly right. Now, up to this point, we couldn't go through and cancel that 9 and that 3 and that A and that A and that 49 and that 7. Yeah, don't do that. If you do that, you get, if it's a 5-point problem, you get 10 points counted off. So, but once we've factored this, now is there something we can cancel?
Yes, 3a minus 7.
Right. Thanks, Aurora. Now we have these two factors, and notice the 3a tied to the 7 here, 3a is tied to that 7, so they can both be canceled out, and we're left with 3a plus 7. Okay.
Is Tim's mic working now? I think it was like.
Tim,
Hello?
are you there?
I'm here. Can you guys hear me this time?
Yeah, I can hear you now.
Awesome.
Okay.
All right. Yeah, I logged back out. So I'll go ahead and do 85, if that's okay.
That'd be perfect.
All right.
Okay, I'm gonna. You may not need this, but I'm gonna tell you right off the bat to put parentheses around that numerator. Okay.
Okay.
Before you get started, if there's a minus sign between the two terms, that's a good start.
Okay. So 3m squared minus 21m minus 30.
Okay, so here we go. 3m squared minus 21m. But what happens if I distribute that negative?
It becomes negative 21 positive 30.
That's right. So make sure, that's a real common mistake, is people just want to apply the negative to the first term in the numerator.
Right, just read it
Make sure
out.
you apply it to both terms in the numerator, and you'll be in good shape. Okay, over.
6m minus 30.
Beautiful. Okay, now
And
what?
then, well, since it's squared, it's going to be 6m plus 30. was going to be 2, correct? Like there's going to be 6m minus 30 and then 6m plus 30 and then another.
No, because when you're subtracting, you just keep the denominator
Okay.
and combine the numerators. So whatever the denominator is, if it's not the same, you have to get it to be the same. And if it is the same, you just keep it and then you combine the numerators. Now what we're looking at is factoring. Okay, can you see anything? Okay, so the first step in factoring is always look for what?
GCF.
GCF. Okay, so is there a GCF in the numerator?
There definitely is. There's
Okay.
6 on each side. So it should be m minus 5
Okay,
for the denominator. My bad.
that's okay. And in the numerator?
Well, we can take the GCF of 3
Okay,
sides. So it should be m minus 7 plus, sorry, 7m plus 10. Keep going.
right. Okay,
And then you can reduce the 3 and the 6.
uh-huh,
And it should be, should reduce plain m squared m plus 10 over 2 m minus 5.
okay. What about the m squared minus 7m plus 10? It's a trinomial.
Right. M squared minus 7m.
Sometimes you can kind of cheat on these a little bit,
Yeah,
but you don't want to rely on that. You definitely want to check it.
yeah.
I think I
So-
did that in my notes.
Yeah, you can really cheat a little bit, but like Matt said, you don't want to rely on it. But what is a really good thing that perhaps might be a factor of m squared minus 7m plus 10 if m minus 5 is on the bottom?
I'm sorry, what are you asking?
Okay, what I'm saying is we're looking to factor this right here,
Oh,
right?
right. We're going to factor the numerator.
So a good thing to start out with is thinking perhaps, and I would say 95% of the time, not always, one of the factors is going to be the same as one of the factors in the numerator and the denominator. So probably when we're factoring that m squared minus 7m plus 10, probably that m minus 5 will be one of the factors. You see what I'm saying?
Case, yeah, so then it'll be, well, wouldn't it be m minus 5m for one of them? And then the other one would be minus 2. And
M minus 2, right.
right,
So m minus 5, m minus 2, right.
right. Sorry, like I'm writing this out as we're going along.
Yeah, because you know that negative 5 plus negative 2 adds to the
Yes.
negative 7, and negative 5 times negative 2
It's a
multiplies
positive
to
10.
the 10. So that's a good way to kind of outsmart the problem just by a guess. That doesn't always work. So you do need to be
I
careful.
always check
about
with the AC method, always.
that. Right.
And then we can scratch out m minus 5, and then our final result is m minus 2 over 2.
Good.
Yeah,
There's
well,
nothing more we can do with that.
I think people are stronger when they do distribution versus when they do factoring. So sometimes if you guess and check, it goes a little quicker.
Yeah. Now, what is something that people might do that is wrong? What do you think? There's something that a lot of people will do that's wrong.
You asking me, Miss Watson?
Uh-huh.
Oh, okay. Sorry, I wasn't know if you're asking the class.
I mean,
They might leave
what-
it at the, I'm sorry?
what do you think someone might do that would be incorrect at this point?
Like at the final result or somewhere
Uh-huh.
steps? They would try and find like terms on it.
Well, they might just try to cancel those 2's.
Right.
So you don't want to do that, right? Because the m and the 2 are tied together. But sometimes
Right.
people aren't really thinking and they just go, oh, those 2's are the same, and they just whack them out. And you don't
Well,
want to do that. So you're through once you get to here.
Awesome.
Okay, so now let's look at the problem that we were talking about earlier, right up here, where we found the lowest common denominator was 12x squared. And so we know that we're being asked to add 1 over 12x plus 2 over 3x squared. And we know we need a common denominator, and we found it. The common denominator is 12x squared. We found that earlier in the problem, in the top of the lesson. Okay, so now what I have to do is make both of these denominators equal to that 12x squared. So what would I have to do to this 12x in order to make it look like 12x squared?
Multiply it by 1 over x.
Multiply it by x?
Yeah, but doesn't it have to be 1 over x because it's a fraction, right?
Well, okay, so if you multiply the bottom by x, what would you have to do to the top?
Well, I mean, if it's 1 over x, then you could just keep the 1 the way it is. But
No.
I don't know if we're allowed to
All
do
right,
that.
because, okay, remember that if you have a fraction, like let's say 2/3,
Uh-huh.
and if I multiply the bottom by 4, that would give me 2 over 12, right? And 2 over
Right.
12 is not the same thing as 2/3, right?
Okay.
So if I
So
multiplied
x
the
over
top
x?
by 4 also, that would give me 8 over 12. And that is the same thing as 2/3.
Okay, so x over x, would that
That's
be?
correct, yes.
Okay.
Because
Because
basically
I
you're
knew
just
it wouldn't be
multiplying.
just x. Yeah, because
Yes.
x actually, as a fraction, is actually x over 1.
Yeah.
Right,
So
which wouldn't
you're
make any
wanting to
sense.
multiply by something that is going to come out to 1. Because if you multiply by 1, you're multiplying, you get the same thing back. So I'm multiplying by x over x. So far I have x, oops. I have x over 12x squared. So I'm good on this piece right here, right? So now I'm looking at the second piece. How can I get 3x squared to look like 12x squared? What would I have to multiply that by?
4 over 4?
4 over 4, yes. Because you always want to be multiplying by the number 1, okay? However, so that's going to give me plus 8 over 12x squared. Now I have a common denominator. So now what do I do?
You just add the top ones together.
And keep the bottom.
Yeah.
What a common mistake is, and people do this, it's kind of funny, but it's not, is they get to here and they start thinking, oh, I can cancel some stuff. And then what happens is they kind of just go in this infinite loop. And so once you've got the common denominator, stop right there and then combine the numerators and keep the denominator. All right, so let's look at 107. And I want to start by, remember when you're finding a common denominator, pick the bigger number. Aurora, I'm going to be asking you some questions here in a minute, if that's okay. And does 10 go into 15, Aurora?
No.
No, right. So what would you do if I multiplied 15 by 2? Does 10 go into 30?
Yes. Yes, I would
Yeah.
use that.
Okay, so far I've found that 30 is the number I'm looking for, right? So normally I'll pick the bigger number. I'll check to see, does 10 go evenly into 15? Nope. So then I try 15 times 2 is 30. Does 10 go evenly into 30? Yep. And if it doesn't, I just keep going until I find one. All right, now for the variable pieces, you always pick the one that has the bigger exponent. So what am I going to pick with regard to the x values?
X squared.
X squared. And what about for the y values?
Y squared.
Y squared, good. So that is my lowest common denominator. Okay, now I have to worry about getting the numerators to be there too. So how can I get 10 to be a 30? What would I have to do to that number?
Multiply it by 3.
What's that over? I'm sorry.
Multiply it by 3.
Multiply by 3, right. All right. Now I have the x squared is okay, right?
Yes.
How would I get y?
3 multiplied by 3y.
Y, exactly. So we're going to multiply both the top and the bottom by 3y, right? So that's going to give me 21y on the top. Now let's do the same thing for the second fraction. What am I going to have to multiply 15 by to get 30?
2
Mm-hmm.
and x.
Yep. And so that's going to give me 8x, right?
Yes.
Now what?
They'll combine the numerator.
Mm-hmm.
1 plus 8x over 30x squared.
Yep, and we're through. Because there's not anything that we're going to be able to divide into 21, 8, and 30. There's no common factor for those. So that's it. So there are a lot more steps to adding and subtracting. Multiplying and dividing is a piece of cake compared to adding and subtracting. Okay. So let's look at number 111. Olivia, will you help me?
Yeah.
Okay, great. All right, so now these are kind of a little bit easier because these are not anything alike, right? They're both totally distinct binomials. So what would be the lowest common denominator for those guys? What do you think?
We would probably have to multiply by 3 on the other side.
So you're going to multiply, actually both of these multiplied together.
Oh yeah.
Yeah.
They're the same letter.
Right. Well, is going to be your lowest common denominator. Okay.
Mm-hmm.
Okay. So far we have 5. Oops. All right. So in order to get this denominator to look like this, what am I going to have to multiply the top and the bottom by?
The second one should be W plus 1 on bottom.
I'm sorry, my dog's whining his way down the hallway right now. So we would have to, yeah.
What are you going to multiply this first fraction by? Because we want the bottom to look like this, right? What did you say? Did I miss it?
I haven't really figured it out yet. My dog came in and whined at me. Well, I guess we would, I mean, it would be a lot easier to multiply the other one, but to make it match, I guess we would do the W plus 1.
That's right. So we're going to multiply both the top and the bottom of this fraction by W plus 1, right?
Mm-hmm.
Okay, now we want to make this fraction have this as the denominator. So what are we going to do there?
Multiply the other one, the 3W minus 2.
Yes. Now here's the rub. Do not FOIL those out. Okay, you're just going to make life way harder for yourself. Just don't do it. So now when we combine these things, before we combine them, we do have to multiply out the numerators, okay?
Mm-hmm.
So if you distribute that 5, that'll give you 5W plus 5. Don't multiply out the denominators. And if you distribute the 2, it's going to give you 6W minus 4. Now what?
Now we combine them.
Now you combine the numerators. So what will you get when you combine 5w plus 5 and 6w minus 4?
11w plus 1.
Yep. And you keep the denominator. And you're through.
I think it's W, it's still W plus 1.
Why do I keep doing that?
Yeah, I think you did it twice. You did it there. And
I don't know why I'm doing that.
getting it across to the W minus 2 probably.
Yeah.
And then can we simplify that anymore? Is what they're probably asking themselves.
Right. Can you simplify it anymore? This thing is totally factored. This 11w plus 1, that 11w and the 1 are tied together. The 3w minus 2, those guys are tied together. The w plus 1 is tied together, and there's not anything that's the same in the top and the bottom. So you're through. Okay, so on this 117, before we can find the LCD, look at these denominators and what do you notice that you probably are going to have to do to them before you can figure out what the LCD is?
Have to factor one of them.
Factor them, right. So how would the first one factor, the bottom of the first one?
Take out the 3.
3. And what about the second one?
It's going to be m squared. Okay, so I guess one of them is going to obviously be m minus 1.
M plus 4, M minus 1?
Right.
Okay, good. So now let's find the LCD. When you have all these factored things, you want to take something of everything. So I'm going to need the 3. I'm going to need the m minus 1. And I'm going to need the m plus 4. So you have to take something of everything if it's factored. Now, if one of those had been like an m minus 1 squared, you would have had to take the square. So you want to always take the factor with the higher exponent. But you don't have to take like m minus 1, you don't have to take it twice. You just take it one time if it's one in one place and one in the other place. All right. Okay, so now I want to make this denominator look like this. So what am I going to have to do to it? Elliot? I want this to look like that.
Multiply m plus 4.
Uh-huh. Multiply both the top and the bottom by m plus 4. Good. Okay, now I want this to look like that. What am I going to have to do?
Multiply 3.
Right. Top and bottom by 3. Okay, so far I'm going to go ahead and distribute this. I'm going to have negative 3m squared minus 12m over 3 times m minus 1 times m plus 4. So go ahead and do multiply the numerators, but do not distribute, don't do anything to the denominator, just leave it like it is. And so 5m times 3 would be 15m over 3 times m minus 1 times m plus 4. Okay, now what, Elliot?
You multiplied the bottoms, right?
Okay, you keep the bottoms. You just keep them.
Oh, okay.
And then you're
Oh,
going to come.
Oh, my bad.
Combine
I forgot
Yeah.
we're still on the.
Yeah, I know. These take forever. So we're going to keep the bottom. And then what are we going to do with the numerators?
We don't cross them out, do we?
No. Okay, so
Okay.
we keep the denominator and we combine the numerators. So I'm going to have negative 3m squared minus 12m plus 15m, right?
Mm-hmm.
And what is negative 12m plus 15m?
Uh, 3m.
Mhm. Okay, so we've done great so far, but we're still not through because we don't know. We might be through, but we don't really know unless we factor the numerator, if it's factorable, and see if any of the factors in the numerator will cancel with factors in the denominator. So can you factor this numerator?
I would have to say probably yes.
Yes. Okay. And what's the first thing you always look for? First thing when you're factoring, always.
GCF.
Right. And if there's a negative lead, then you want to include the negative. So you're going to have a negative 3. And what else do they both have in common?
They have a m in there.
They have an m, right? So if I took the numerator, negative 3m squared plus 3m, and divided both parts by negative 3m, what would the first part turn into, the first term of the binomial?
It would be m minus 3.
M minus, what's 3m divided by 3m?
Oh, my bad. m minus 1.
Yeah, yeah. Okay. So far now, then what we have is 3m times m minus 1 divided by 3 times m minus 1 times m plus 4. Yeah, I'm not going to do that. I don't like that. Okay, now we've got everything factored. We really don't know if we're through until everything is factored as far as we can factor it, because unless everything's factored, we don't know if anything will cancel. At this point, will anything be able to cancel?
Would 3m.
The 3's would.
Yeah.
And then what else?
The m minus 1.
The m minus 1. So what are we left with on the top?
M.
Negative m, right? Because that
Negative
negative
m.
did not cancel, correct?
Yeah, negative m over m plus 4.
M plus 4. Okay. Can we cancel this m with this m?
Yeah.
Okay, watch it. This plus sign ties those two things together. Okay, it's like a rope that are handcuffs. You can't cancel one without the other. You see what I'm saying?
Yeah.
So you cannot do any more than that. That you have to stop right there. So that would be your final answer, negative m over m plus 4.
Yeah, I was gonna say maybe it might help them if they like put parentheses around the numerator and denominator, because like in your mind, what you should see is like parentheses. I have parentheses there and there. That division bar separates them, right? But and there's kind of like an understood parentheses there. I have to do all the numerator before I do the denominator, right?
Right. The division bar is like, it really is like a parentheses. It really is like saying put parentheses around top, put parentheses around the bottom.
So somehow in your mind, like if you got to put your thumb over m plus 4, that is like one being right there. If you see it in parentheses, that's like one factor.
Yeah, this is one thing. That plus sign is a rope or handcuffs that tie those two things together.
Each set of little parentheses is each a separate factor, right? And they got to match up exactly if you want to simplify them, right?
Okay, so let's look at 125 and let's see.
It's all right, Miss Watson. I'd like to give this one a crack.
Oh, I'd love it.
Awesome. Okay. 6 over m plus 6 minus 12m over m squared minus 36. So for the denominator, we can go ahead and factor out m squared minus 36, which should come out to m plus 6 and m minus 6.
Yep.
We can just rewrite that as 6 over m plus 6 minus 12m over m plus 6 and m minus 6.
Okay, so our LCD is what? What's the LCD?
Oh, m plus 6 and m minus 6?
Yes, it is m plus 6, m minus 6. Okay, so now I'm working with the 6 over m plus 6. And what are you telling me to do with this first term?
Cross it out?
No.
No.
You tell me what to do with it?
You just said it. No, sorry, my bad.
So
All right.
what do I do with it?
With a 6?
6 times what?
6 times 2m. We gotta make it the same on both sides.
Right, so that would be m minus 6, m minus 6. Is that?
Oh, I said something completely different, but I guess.
Is that what you meant me to do or not?
No, I said something different. I thought we were trying to make the 6 into the 12m the same.
Okay, no, what we're trying to do is get the denominator
Yeah.
to be the same, right? So we're trying to get both of these guys to look like
To look
that.
the same. Right. Okay, now that makes sense.
Now what about the bottom here is already m minus 6 times m plus 6, right?
Right.
So do we need to do anything to that one?
I don't think so.
No, right. Because the denominator is already what we want it to be, right?
That's already factored out.
Yeah. Okay, so now what's the next step?
So go ahead and distribute 6m minus 6.
Okay.
6m minus 6. So it should be 6m minus 36.
Okay.
Minus 12m.
Good.
Okay.
Okay, and then how does that simplify? I mean, what do you do from there?
We can just factor out the numerator.
Okay, so can we combine anything in the numerator? What, like 6m and?
Combine? Yes, you can.
Okay, so what can you combine in the numerator?
6 and negative 12m.
Okay, and what's that going to give you?
Negative 6m.
Yes.
And then minus 36.
Okay, now can I factor anything else out of the numerator?
Yes, you can. You can take negative 6 from 36.
Great. So negative 6. And what's left? When we divide negative 6 into both parts of the numerator, what do we get?
M plus 6.
M plus 6, good. Okay, and now what?
And m plus 6 cancels out.
Good.
And you're left with negative 6 over m minus 6.
Right.
Awesome.
And nothing will cancel from there, right?
Right.
Okay. Good.
So
Awesome. Thanks.
I noticed they gave them problems that like don't have this issue, but like doing like 3 minus x versus x minus 3.
Oh.
And like how those relate to each other.
That's okay. So let's talk about that for a minute. So let's say we had 3 minus x over x minus 3. What would you do there? Or how could you make these two things be where they are something that's alike?
I'm guessing we're gonna have to multiply.
Multiply. Well, Okay, so usually we're not multiplying unless you're multiplying top and bottom by a common factor. But what about dividing by something, like factoring out a -1?
If you write in descending order, it might also
Help 'em.
make more sense
Okay.
to do it. Because then we can follow our rules as well.
Right.
To factor out a GCF of
Good,
minus
yeah.
1. Yeah.
So if we rewrote this as -x plus 3, and you always want to factor out a negative if there's a leading coefficient that's negative. So if I factor out a negative from here, what do I get?
X minus 3.
Yeah. And then what?
You factor out those two
Mm.
parentheses.
And you're left with, what are you left with if you factor?
Well, wait, if it's -1 over 1, that's the same as -1, right?
That's right.
This is a property that they know if they just step back and think about it. If I do
Uh-huh.
3, if I do 5 minus 3, I'm going to get +2. If I do 3 minus 5, I'm going to get a -2. They relate by a factor of a negative, right?
So one thing, if you notice, like for example, let's say you had 5x squared minus 3x plus 6 over -5x squared plus 3x minus 6. If you notice that the polynomial in the numerator and the polynomial in the denominator are exactly the same, except signs are opposite, it'll always come out to be a -1.
Oh. Okay.
So if you look at this one, 3 minus x over x minus 3, that would be the same thing as -x plus 3 over x minus 3, right? And they're exactly the same, except all the signs are opposite. So that means it's always going to be -1. Okay. So we are looking at this last one. Would someone like to volunteer to help me with it? Anyone? Gabby, Leticia, Monica?
Well, if it's +3, that's actually +3 over 1, right?
Good, thank you. Okay, thank you, Michael. Yes, so I'm going to go ahead and write that out, okay? So this is 2x plus 7 over 10x minus 1 plus 3 over 1. Okay, so Michael, will you continue?
I mean, the lowest common denominator is easy. You just literally take the left side and just multiply it by the right denominator to get the least common denominator.
And so what is the least common denominator?
Well, it's 10x minus 1.
That's right.
Okay, so.
Okay. So do I need to change this fraction at all?
Oh, wait, no. So
No.
you have to multiply the 3 also by 10x minus 1.
Okay, good.
Okay, so now we're gonna have 2x plus 7 over 10x minus 1. Add 2, 4x plus 14.
Okay, hold on. Slow down. Slow down.
Oh, sorry.
All right. So what's the new numerator for the second fraction?
4x plus 14. At least it should be, I think, because you're taking 3, or wait. Okay, no, I was doing 2. Okay, so it's 3. So it's actually 6x plus 21.
I am confused.
I think he's looking at
Aren't we multiplying 3 over 1 by 10x minus 1 over 10x minus 1?
Yes.
Don't we have to do that?
Uh-huh.
So I'm multiplying it.
You're multiplying the wrong polynomial there, or whatever.
We're supposed to leave that alone?
It should be the 3 and the 10x minus 1. You said it right, and then you did the wrong thing. Like you're multiplying by that 2x plus 7 for some reason, and I'm not sure.
Oh, whoa, yeah, I got mixed up there. I was,
now I see.
why.
yeah, you're right
I was
about that.
totally confused. I'm like, okay. So,
Sorry. Yeah, 30x
no.
minus 3 then.
Yeah. Okay. So what now? Say it
30x
again.
minus 3.
30x minus 3. Good.
Yeah, I don't know what's.
He was saying it right, but he was
Yeah.
doing it.
Yeah, I was looking at the wrong thing.
Okay. Now what?
And
Michael?
10x over 1. So now all you have to do is add the 2x plus 7, add it to the 30x plus 3. Yeah.
And
so
what will you
that's
get?
32x plus 4.
Great.
Oops.
I might be through, but I might not be through. So I don't like to finish. I don't like to say I'm totally through unless everything is completely factored.
Yeah.
So could I factor the numerator?
So like you could make this, I don't know if we're allowed to do decimals, but I mean like you could do.
No, but is there a number that'll go into 32 and 4?
Oh, so we're pulling out, okay, because I was going to try to take 32x and see, I'm still kind of confused on how to do that. I was trying to mess with the 32x and the 10x.
Oh,
So
no,
we're
you
not gonna do
can't.
that. You can't.
You
okay.
can't, right? Because they're tied. These
They're
guys are
tied to the
tied
other number.
together.
Okay.
These guys are tied together. Okay.
Ah, okay. Yeah. So I
But-
mean, if you want to find the LCD of the 32x plus 4, that's 4. And so that would give you 8x plus 1.
Mm-hmm. Now are we through?
I don't know what else I could do with that.
There's not anything else
Okay.
you could do, right? So
Yeah.
really and truly, if you stopped here, that would be okay, because there really is nothing else we can do. But I always like to make 100% sure. So if anything is factorable at the end, if the numerator, anything is factorable, I go ahead and factor it just to make 100% sure that nothing will cancel.
Yeah, I mean, at that point where you see 32x plus 4, you might be able to tell like 10x minus 1 is not going to be one of those factors. Just knowing what you know about polynomials at this point, right? It's not going to factor evenly to 10x minus 1.
Right.
But yeah, you really should carry it all the way. That's what I would suggest.
Me too.
Let's say there was a factor.
This would be, and this would be fine. If there was, then you'd factor it out. You'd cancel them out.
Let's say it's 32x plus 4 over 4x minus 1. Would you be able to do anything with that?
I think 32x minus 4 maybe. That the top would have to be negative too, I think. Is that what you're
Okay. Because I'm just saying, I mean, like, is there scenarios where we can start?
Oh yeah, definitely. Like if this factored to match the 10x minus 1, like if you had 4 times 10x minus 1 on the top, then you could cancel. And that happens a lot of times.
Okay.
Yeah.
It would have to be 32x minus 8 over.
Yeah. So let's say you had, this is just hypothetical. Let's say you had 32x minus 8 over 10x minus 1.
4x minus 1, right?
Oh, okay.
Is that what you're trying to do, make it factor evenly?
Yeah.
Yeah, because I'm thinking about factors that they would have in common, but how we would approach it.
Let's say you had that.
Okay.
Then you could factor out the 8, right?
Okay, so first you factor them individually before you do that.
Right. And then if the factors, that's why I said to factor it, because these two might be the same. And if they are, then you can cancel them. But they're not in this case, so we just leave it alone. So if you had left your answer like this, it would be correct. And if you left it like this, it would be correct. But if you left an answer like this, it would be partially wrong, because you could continue to reduce it.
Okay.
It's all the same steps that you do when you subtract fractions that aren't polynomials. You got to find a common denominator. You got to actually do the addition subtraction. And then the last thing is you got to factor and simplify.
Mhm.
You just probably don't think about factoring really like a whole lot when you do just a number. You're just probably thinking about it more now when you do a polynomial. Because they look crazier.
Yep. You get a common denominator, you keep the denominator, combine the numerators, and then you simplify. And a lot of times, simplify, you have to factor the numerator to see if anything will cancel with the denominator. Would anyone like to see any more examples?
I say yeah.
Yeah, okay. Let's see here. Let's say, here's another example. What would be the first thing you would do on a problem like this?
The least common denominator.
Okay, we want the least common denominator, right?
That would be x minus 2.
Okay, so look at this. If an original denominator can factor, that's the first thing you want to do, is factor.
Oh,
Can you factor x squared minus 4?
yeah.
How would it factor?
X minus 2, x minus plus 2.
That's right. Thanks, Aurora.
It's Gabby.
Oh, Gabby, I'm sorry. Oh, gosh. Thank you, Gabby. All right. So x minus 2, x plus 2. And so now what is the lowest common denominator?
Oh, okay, so it's x minus 2, x plus 2.
Yes,
That's
because
the least common denominator.
remember, you
Okay.
take something of everything for the lowest common denominator. So you need an x minus 2, and you also need the x plus 2, right? That's going to be the lowest common denominator. Take something of everything.
Okay, okay.
And if anything is to a power, you always take the highest power. All right, so now we have 2x over x minus 2 times x plus 2. So do we need to change that? Do we need to do anything to that to get the common denominator?
Not to that side of it, no.
Not to that side, no. And what about the 1 over x minus 2?
You're gonna have to multiply x plus 2 on the top,
Right.
numerator, which is just gonna be x plus 2.
Okay. Now what?
And then, I mean, at least we can do the, I mean, so at the top, you just make it 2x minus x plus 2.
On the top?
Yeah, on the top. Because
We're
the
gonna do
1
what?
is you can just get rid of the 1.
Okay, and just make it an x plus 2?
Yeah, so it's 2x minus x plus 2. But the denominator is already taken care of.
Okay. So now what?
Okay, well, I mean, I would have written that as just like one thing because
Okay,
the denominators are matching. Yeah, like that, and then over the denominator, yeah. And then you can just factor out the x plus 2. But wait a minute, if the x plus 2 is negative, doesn't that affect the factoring out? Because the one at the bottom is positive. Right.
you're gonna have to
So-
combine you're gonna
Okay.
have to multiply that -1 and then combine like terms.
Okay, so it's negative x minus 2.
Right.
Okay,
And how does that simplify?
x minus 2, which you can then factor that out.
What happens when everything cancels in the numerator?
Well, it's just a 1. That's all you have
Just a
left over.
1.
Could you go to the top again? Yeah, it's very eerily similar to the beginning of it because that was 1 over x minus 2. Yeah, it doesn't seem. Yeah, I guess it works out, but it.
Yeah.
Yeah, these are kind of weird how the math works out.
Yeah, that's just a coincidence that it. Yeah.
Yeah, and if it simplifies out and you're getting 1 in the numerator, that's different from getting 1 in the denominator. So a lot of times people will like try to put just the factor there. But if that factor is left in the denominator, it's over 1. So don't forget to put it over 1.
Yep.
Make sure you know whether your factor's in numerator or denominator. It makes a difference.
Do one more. What would be the common denominator here?
X plus 1, x minus 1?
Yes, x plus 1, x minus 1. So what are we going to have to do to this first fraction to get the denominator to look like that?
Multiply both parts by x minus 1.
Yeah, multiply top and bottom by x minus 1, right? What are we going to have to do to this fraction to get the denominator to look like that?
Multiply it by x plus 1.
Right. Now what?
We can distribute both parts of the numerator and then
Right.
combine.
So now what?
Would you add the negative x together? The negative x plus. Okay.
X squared.
Minus 4x.
Mm-hmm.
Minus 3.
I just kind of made this one up real fast, so I don't know. I don't think that x squared minus 4x minus 3 is going to factor.
No, I would have to quadratic formula that, I think.
Yeah. So this is as far as you can take it. Now, if you could factor it, you would, but you can't factor that numerator. Okay, well, if you have any trouble with the homework, let me know and I'll be glad to get back on with you over the weekend and work with you through it. Otherwise, we are through for the day.